Okay, so let's go ahead and get started. Today, I'm not going to do Lab 5 yet. I'm going to wait till next class because I have a handout I want to give you with that. Lab 4, we're going to skip. We're not going to do Lab 4. Today, we're going to finish up 6.1 and then start in on 6.2 and finish that, pretty much finish that one as well. That's the whole areas of normal distributions and applying those to real life problems. You have Connect Math 5.3 today, along with Project Part 3, right? So I need that today, but it does not have to be colored like that. All I need are your table, your table and your chart. That's it. Table and chart. I don't need your data, but I do need that by. I'll be here probably till about 10:10 tonight. So I need that by then. It's late, but you can still get full credit if you turn it in tonight. Thursday, you have Connect Math 6.1 due. Sunday, you have a Sunday homework due, 6.2. Also, for the z-scores, we're going to use 2 decimals. And then for areas of these normal distribution curves, we'll be using 4 decimal places. And then finally, next Tuesday, you have your Connect Math 6.3 due because your exam is next Thursday. So you have an exam a week from Thursday. It's going to cover chapters 3, 5, and 6. I'll do a review session for you guys next Wednesday in 6:01 from 6:30 to 8. Who can actually make that and can get there by 7 at least? Okay, so who's actually planning to go? Of you who are planning to go, who can get there at 6:30? Who cannot get there at 6:30? Okay, so a couple of you guys are going to be a little bit late. I'm sorry? Okay. All right.
Is there another day that you have?
No, I kind of don't because I'm here. But okay, the other thing too is next Tuesday, I'll be here after class. So stick around, plan to stick around after class on next Tuesday and ask me questions then. Right? Because I'm just here, just answering questions and hanging out. So feel free to just ask me questions about that then. That's a great time to ask questions. So this is what exam 2 covers, just in case you guys need a reminder. There's 2 parts. The first part is no calculator or a very, very, very basic calculator. Just add addition, subtraction, multiplication, division, basically. Maybe square root if you want. Which means that if you have to do a square root and you have a square root on it, you can just put like square root of 19 and leave it like that. That's fine. The TI calculator is allowed for part 2, so you'll do your first part. You'll finish it in 10 to 25 minutes. You'll turn it in. You'll pick up your second part, and then you'll work on that one with your calculator. There'll be 2 colors. Whatever your first part is, pick up the same color. Right? If you're turning in a pink test, pick up a pink test. Or whatever colors I decide on. I don't know. Okay. It covers these chapters, but not 6.4. And again, you're allowed one half page of notes handwritten by you. So, again, you can do a half page here. If you had your chapter 1, your exam 1 notes on this one, you can use the back side for that, half page there, and then you can use this side for exam 3, and then your final. That's totally fine. We talked about that before, so that totally works. All right. Good. Let's go ahead and start. Juan, go ahead, read.
The mean, variance, and standard deviation of the variable that has a binomial distribution can be found by using the following formulas.
Great. So remember, binomial is my favorite because the mean and standard deviation are super easy to compute. The mean is just NP. The variation is just NPQ. Standard deviation is just the square root of NPQ. The binomial centers around these 2 things, N and P. So how do you tell apart one binomial from another? They'll have a different N and a different P. That's all you need to determine how a binomial distribution works. They're just those 2 numbers. Those are the fixed things for any binomial. your quiz problem number 1 is this. I think it's like, and see if it's red or not, right? All right. So, what kind of distribution is this? Anybody? What kind of distribution is this? Binomial. How do you know it's binomial? Because something is happening over and over again that only has one of two outcomes. What's happening over and over again that has a yes/no outcome?
We were not red or not.
Yeah, you're drawing a marble, and it's red or not. Does that make sense? So that makes it binomial. It's not what color is the marble, because then that wouldn't be two different outcomes. Red or not. You're drawing it over and over again. So then the next question is it only happening a fixed number of times? Do you know before you start how many times you're going to do this? Do you know when I'm going to stop? I'm going to keep drawing it forever, or do I know when I'm going to stop? 12 times. That's my n. The number of times you do it. So then I know that, okay, it passes the first one, something's happening, or the second one, something's happening over and over again with only two possibilities. I know when I'm going to stop. I have an n. The last thing is, do the probabilities stay the same for each draw? So every time I draw a marble, is it the same probability of drawing a red marble? Yes, because it's with replacement. What is that probability? What's the probability I draw a red one? What's the probability I draw one marble and it's red? 3 out of 10. So everybody see where that's coming from? So this part here, three out of 10, that's my p, my little p. Little p. And then this part here, I'm drawing 12 times the replacement over and over again. That's my n. Should we do that? That's my n. So, my p and my n are fixed. P is 0.3, which means that my q is what? 0.7, and my n is 12. That stuff is fixed. Then I have a variable. A variable is something that varies, changes, has different possibilities. That's my x. X is my variable. It can be anywhere from 0 successes to 12 successes, right? Anywhere from 0 to n. It varies. Depending on what x is, you can find the probability of x at that point. I would never bother finding the probability of n because I know what the probability of n is 12, 100%. What's the probability of n is anything else? 0. It doesn't vary. Do you know what I'm saying? But this varies, so I can find the probability of it being different things. The probability that's 1 or 2 or 3 or 4. So that's what I'm going to find the probability of. Do you guys remember the binomial formula? Right, it's n choose x times p to the x times q to the n minus x. Yes? So hopefully you guys have employed it here. So you've done 12 choose 2 times my p is 0.3 to the second times my q 0.7 to the 10th. And you guys do all that. You got 168. Good. Okay. Then find the mean and standard deviation of this distribution. Mean is NP. N is 12. P is 0.3. 3.6. My standard deviation, sigma, is square root of NPQ. Square root of 3.6 times 0.7, because this is NP already. And you guys, what did you guys get for this one? Everybody do it. If you haven't done it, do it now. 1.59. Or 1.6, either one's fine, I don't care. Okay, do you guys need 30 seconds of your day to discuss all these? Yes, no? No?
Sure.
That was a no or a yes? Yes? Okay, take 30 seconds, go ahead. And what I'm writing is what I want from you guys in terms of you showing your work. I want you to give me this, and then the answer. Good? For this one, I want you to give me mu. You don't give me that, but give me mu, this times that, the answer. Right? Standard deviation, this square rooted, answer. All right. You guys remember this one? Z-score. It's how far and how many standard deviations a value is away from the mean. Right? It should be negative if it's below the mean, positive if it's above the mean. But it's how many standard deviations you are away from the mean. How do you find it? Oh, it's also called the standard value, just as to kind of point that out. How do you find it? You find out how far your value is from the mean. You find the difference. If it's positive, it should be, if it's above the mean, it should be positive. If it's below the mean, it should be negative. And then you divide by standard deviation to find it in terms of how many standard deviations that is. This is the formula in terms of symbols. If you don't have that handy or don't know it offhand, you should write that down because you're going to need it in about 3 or 4 minutes. Maybe 10 minutes. Maybe half an hour. But you'll need it soon, today. Okay. All right, this one here. Okay. Austin, go ahead and read for me.
Chapter 6, Normal Distributions. The shape and position of the normal distribution curve depend on two parameters, the mean and the standard deviation. Each normally distributed variable has its own normal distribution curve, which depends on the values of the variable's mean and standard deviation.
Right. So for a binomial, it's all about n and p. N and p tell you what the shape is and where it is and everything else. For normal, it's all about the mean and standard deviation. You know those two things, you have everything you need for that normal distribution. It gives you the shape and tells you where it is. So for example, right, the mean tells you where it's centered around, and the standard deviation tells you whether it's a spread out hill or really like skinny tall hill, right? It tells you the shape. If two samples have the same distribution around the mean, they will have the same standard deviation. So for example, if I take these numbers, 1, 6, 7, 9, and 12, and I add 2 to every single one of them. Add 2, add 2, add 2, add 2, and add 2, then I get these numbers here. If these numbers have a standard deviation of 4.1, then these numbers will also have a standard deviation of 4.1. Because their shape hasn't changed. They all just have been shifted up 2. You guys remember that football huddle we did where everyone shifted over 2? Their shape stayed the same. Their standard deviation stays the same. It's just that their mean, their average has shifted over. Here is another example. Maybe it's a little bit better. Numbers 1, 2, 3, 4, 5. They have a mean of 3. Everybody on board with that one? If I add 2 to every single one of those, I will get 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6, 5 plus 2 is 7. These have a mean of 5, yes? Okay, good. Then I need to find, so adding 2 to every one of them increases their mean by 2. What about saying standard deviation? How to find the standard deviation? How far each value is from the mean. How far is 1 from 3? 2. It's 2 below it. How far is 2 from the mean? 1 below it. How far is 3 from the mean? 0. 4 is 1 above it. 5 is 2 above it. Yes? And then what do? That's my x minus x bar part. But I need x minus x bar squared. Right? That's the second step. So we square all these. 4, 1, 0, 1, 4. And the last part is I kind of average them. I add them up, divide by, if it's a sample, divide by n minus 1. So let me add them up. And divide by, and what's my n? How many of them are there? 5. So 5 minus 1. So I will end up getting 10 over 4. That's my standard deviation. Or that's my variance. Sorry, we'll start with that. Now, let's look at the bottom one. How far are each of these from the mean? How far is 3 from 5? -2, 4 is -1, 0, 1, and 2. But wait, look. These numbers, oh, I should have done them in red. Hold on. My bad. I'll make it easier to spot. -2, -1, 0, 1, and 2. These numbers and these numbers are exactly the same. Exactly the same. So then when I square these and then add them up, divide by n minus 1, I'm going to get the exact same thing I got above. Because these numbers and those numbers are exactly the same. How far each of them is away from the mean is the same. So their standard deviations are going to be the same. Make sense? So as long as you do it uniformly to every single one of them, how far each one is from the mean hasn't changed. Because they've all shifted together. Okay. The other thing I wanted to review was you will get on the homeworks and or in the exams times where I say either use the empirical rule or I say estimate for a normal distribution. If I use either one of those, that means you should use this 68, 95, 98.7 rule. Right, which means that 68% of your data lies within 1 standard deviation, 95% of your data lies within 2 standard deviations, and 99.7% of your data lies within 3 standard deviations. Good? Only when I say approximate or use the empirical rule or use the 68, 95, 99.7 rule. Any one of those are kind of all the same thing. Yes? Good? Okay. But your clue to use these is the word approximate. Otherwise, you'd use normal CDF to find the exact number. Okay. And I think we did normal CDF last class of like -1 to +1. We got 0.6814 or something like that. So it's very close, or 0.6828, 26 or something. So it's very close. It's just slightly off. Okay. What's the area underneath this curve? I add it all up. 1 or 100%. And the empirical rule can help us estimate if our z-scores are whole numbers. But a lot of times, most of the time, they won't be. Right? Like 64 inches would be here, or you'd get like other numbers, 63.28, they'd be in here. Their z-scores are not whole numbers. So what we've done is, if you convert it to a z-score, they've made tables for every single possible z-score with up to like 100th of a z-score. So like 1.06, 1.07, 1.08, right, all those. And they found the areas below it, because often we want to know what percent of the population is below something or above something. It's also locked into your TI-84 calculator. So that entire table has been saved and input into this calculator. So they're all in there. And we're going to use normal CDF to find those areas. How do you do that? You find the z-score, and then you do normal CDF of the left z-score, or the lower z-score. comma, the right or the upper z-score. And this is them right here. This is the lower one, that's the upper one. Right, the lower one or the left one is the one over here. The right one is the upper one over here. So feed it these two z-scores. What's up with the z-score that's way over there? If it goes off, from here and greater, if it went from this point and greater, what would be that z-score way over there? What was that? I can't hear anybody. Anyone? Z-score way over there? Infinity, right? Or you could use any large number. Like your age is large enough, that's fine. But z-score is infinity way over there. What's the z-score way over there? Negative infinity. Good. Thank you for saving me. Okay. So this is one of the things we did last class. I'll do it one more time just to kind of refresh people. Is the first thing I want you guys to do, everybody needs to do this. If you don't do this on the exams, you are going to lose big points. First, draw a bell curve. Then draw a line along the bottom with a little notch in the middle. That's where your mean is. Then find your z-scores. What's my z-score? Negative 1.14. Where is that? On the left side or the right side? Left side. Over here. I want it underneath. Don't put it above. I want it below. 1.14. Then draw a line up to the top, and then shade. Area to the right. Which side's the right? This side or this side? This side. Okay, good. So then we're going to shade our area to the right. And then figure out what the other z-score is. In this case, it's going to be way out here. So it's going to be infinity. Good? Everybody on board? So then I'm going to do normal CDF of negative 1.14, comma, any large number will do. You can put in 30 there. You can put in your grandmother's age. Whatever your grandmother's age is. What's your grandmother's age? Anybody know their grandmother's age? 87, great. 84. Either one of those. Perfect. Put it in. And you'll get this. 0.8729. That means that 87.29% of the population, this area here, is more than negative 1.14 standard deviations in the mean. So it means that from here on here, 87.29% of the population represents all these values or all these spots out there. If you add them all up.
How did you get to 87?
Normal CDF. So that's a good question. How do you do normal CDF? Like this. Actually, yeah. Using your, well, first of all, before we do that, let's do this. I want to find the probability that z is greater than 1.98. Incidentally, that's the same thing as a probability that z is greater than or equal to 1.98. Do you guys see these two things here? The only difference is this one is just strictly greater than, and this one's greater than or equal to. Why are they the same? What's the probability that this sheet of paper is exactly 11 inches? Exactly. 0. Because it's always going to, no matter what I do, it's always going to be 1/1,000,000th longer or 1/10,000th shorter or something, right? And so you're never going to be able to get it exactly 11 inches. It's impossible. Because there's infinite number of possibilities in that range, right? So 1 over infinity is 0. And you can also look at it like areas. 1.98 is just this line here. What's an area of a line? It has no thickness. It's 0. So that's why whether or not you include this doesn't matter, because theoretically this probability is 0. Anytime you have a continuous distribution like normal, a normal distribution is continuous, then you have to find the area between 2 points, because the probability any one point is going to be 0. You have to find the area between 2. Okay, so we need to find the area from here and greater than. So this is this way. If you're not sure what these little symbols of greater than, less than is, I use Nemo for that. Here's my Nemo. So I draw my Nemo. and he ate the smaller one because the smaller one's easier to catch. The Z is bigger, it's harder to catch. So 1.98 is smaller and Z is larger. So the larger ones it's harder to catch than the little ones. Okay. So here, what's my left Z-score here, guys? What was that? Right, and then my right Z-score, this goes on and on forever out to here. So what's my right Z-score? Infinity. So here I'm going to do normal CDF of 1.98. And then you can pick any large number you want. 87. Great. Grandmother's age. Perfect. If I do that, this is just notes. Then you'll get, you guys with me here, stay with me. I'm trying to explain this to you guys so you guys have it. Then you'll get 0.0239. What does that mean? That means that if you randomly pick somebody and say, I want to know about height, I randomly pick somebody, there is a 2.39% chance that their height will have a z-score of 1.98 or larger. Does that make sense? Okay.
Is that how we write it out on the exam? The answer? Or do you just, can you just put
This is what I want.
Okay.
And then you don't have to use 999. You can use any large number. The problem with people using 999 is some people get confused and they start putting 1.999, which is not a large number. So that's why I say just use any large number you want. You can use your age, your mother's age, your grandfather's age, any age you want. Just pick a large number. As long as they're over 10 years old, it's a large enough number for z-scores. So then the question is, how do you find it with normal CDF? Second bars, and then pick, and it actually starts with distribution, and then go down to the second one. Normal CDF, not PDF, CDF, and then put in the left z-score, comma, the right z-score. Use negative 99 to go all the way to the left, positive 999, or any large number, and negative 87 to go all the way to the left, and positive 87 to go all the way to the right. If you have a fancy calculator, anybody have a fancy calculator? Then you're going to get something that says upper and then lower. So you put the lower than upper. So you put the lower one in the lower spot, and you arrow down, and then instead of doing comma, then you'd put you'd put negative 87 in the lower, and then you'd arrow down and put 1.2 in the upper, and then leave your mean at 0 and your standard deviation at 1. Do you guys hear that? Fancy calculator, mean of 0, standard deviation of 1. And then you'll have to go down and hit enter, calculate, and then hit enter again, and then it'll give it to you. Yeah?
For this last one, so the lower would be 1.98, and then the upper would be whatever big number we want.
Yes.
Okay. It wouldn't be negative just because the 1.8 is smaller.
Right, let's try that one. So I'm going to bust out your calculator and give it a shot. So here, second, right there, this upper left corner, and then bars, which is right here by the arrows, kind of. Has anyone got that so far? Second, and then bars. And then go down to normal CDF, the second one down. Enter. And you wanted, what do you guys want?
1.98.
1.98. And the comma is right above the 7. And pick a large number, 84. Perfect. Enter. 0.02385, so it rounds to 0.0239. All right, so quiz problem number 2 was finding the indicated area under the curve of the normal distribution. So, first thing is, draw a picture. Draw a hill. If you did not draw a hill in your quiz, draw it now. Then, put a little notch in the middle. Everybody has a picture on their quiz? Picture on your quiz?
Picture on the quiz.
A lot of pictures on your quiz?
Is it not?
And then, what's my z-scores that I can't put a notch in the middle? And then what are the z-scores that I care about? Negative 2.2, is that on the left or the right? Left, so put it in. Negative 2.3. And then, well, positive 2.3, that's on the right. I don't really care about where it meets one. If it's negative, it better be on the left. If it's positive, it better be on the right. And I want between those, so I'm going to draw those all the way up. Those are the two I care about, and I'm going to shade in between them. So shade. Shading is not hard. It will save you half a point. Is it worth shading for half a point on the exam?
Yes.
Yes.
Can you use color?
Yeah, you can just do lines like this. That's fine. Just do like that. That's fine. I don't care. Is that what you're asking?
Kind of highlight across.
Oh yeah, totally. All right, and then I need to find this area. So everybody do it. Normal CDF. What's my left z-score?
Negative 2.9.
Yep. Don't forget, if you need a negative number, you cannot use a subtraction symbol. You've got to use that little negative next to the enter, right?
But you don't put a big number?
No, because you want between these two.
Okay.
You want from here to here, so you put in this one and that one.
But if it's like, you only want one.
If I wanted from here to infinity, then I'd have to use, if I went all the way out, then I'd use a big number.
Okay.
But if I just go from here to here, I just put in those two.
Okay.
Yeah.
Thank you. Makes sense.
And again, if you got an error, that's because you probably used the subtraction sign instead of using the negative symbol below your, next to your equal sign, your enter symbol. So what did you guys get? 4 decimal places.
I don't know what flag, but God.
Okay, so it sounds like everybody has this. What did you guys get? 95. Give me 4 decimal places. 5, 5?
Or 6.
8.5. 97.85. 8.6 or 8.5? 8.5. Okay, good. And when you round, that's right? The next decimal is a 4 or lower?
No, it's higher.
It's higher, so then it should be 6.
Yeah, that's right.
Don't forget to round.
You round to
So you need the next, so 0.9785, what?
5.
5. If you want to go to here, you need to look at the next one and see what it is. If it's 5 or more, you got to round up. Okay. So let's take a look at this one. So here it's probability that z is less than, I think this is in your notes, right?
Yes.
Probability z is less than 1.73. So less than it means on the left side. What's my left z-score, everybody? Adam, what do you think my left z-score is here?
1.7
That's my right z-score. What's my left z-score?
infinity.
Positive infinity?
Negative.
Negative infinity. Everybody understand that? Draw it out here and put it in. Negative infinity. Vanessa, what's my right z-score? I'm sorry, what was that? What's my right z-score? 1.73. So then I'm going to do, Sterling, I'm going to use normal CDF of what?
Well, just like negative 900 or 9.
Great, 900, comma.
1.73.
Uh-huh. Everybody do it. Do it, do it. Everybody do it.
Question real quick.
Yes.
When you're doing the normal CDF,
Uh-huh.
it has to be the order
Yeah, so when you do normal CDF, you have to put the lower one first and the upper one second, or else you're going to get a negative area.
Yeah, third page, right here. Basically, the point when you guys negative, then you just do kind of small numbers. Looking at you guys, please go over like.
It could be any big number, you said too, right?
Yeah.
Yes.
Okay, sorry, I'm not.
Derek, what'd you
I
get?
mean, that's way smaller than that.
0.9 what? 582. Great. So guys, look up. So it means that this right here is 0.9582 inside of there. So what's the probability that Z is less than 1.73? 0.9582. What does that mean in words? 95.82% what?
Of the value are within 1.73 standard deviations of the mean.
Oh yeah, the values are less than. The values are less than 1.73 standard deviations of the mean.
Right.
So, do you guys follow where that comes from? Yeah.
Wait, is this, the percentage is the same as the area because it must all be?
Yes.
Is that right?
The percentages is the same as the area. Totally.
Because it's all one, the area, or.
So the area under the curve, we're going to talk about that in a couple minutes actually.
That's what I thought.
First of all, why don't you guys do lab problem? Yeah, do lab problem 1. Yeah. Lab problem 1 has